Hey, you 13s, it's good to see you. People already appearing on the chat, which is nice. Hi, Nikita. Hi, Dan. Hi, Mika. It's so nice to see you all. We are continuing with equilibrium. How exciting. Just going to do the reg. I bet most people are here. We're continuing with equilibrium. Oh, I just... How exciting. I think my mic's off again. I think I'm going to pull out my mic and plug it back in. Unmute microphone. Is that better? I think that'll be better. In fact, I know it will be. I know. Right. Wow, everyone's here. Check this out. Are we going to be going through the test? Ah, yes. Oh, no, I didn't plan for that. Means I have to change my YouTube thing. I've got Dat, I've got Ria, I've got Jasmine. Seen those. Dat, Ria, Jasmine. I got Kayoon. I didn't see Kayoon. Yeah. Got Kayoon. Did I see Ben? I think I saw Ben. Yeah. Got Ben. Tenzi? I see Tenzi. Yeah, I did see Tenzi. Tenzi, Ivan, Dana. Tenzi. Sherlyn, of course, not here. Oh, I don't do that. Emma? Do we have Emma? Oh, Emma's there. Amazing. Smashing through the reg. Ivan, I've seen. Nikita, I've seen. Mika, I've seen. Dana, I've seen. Full house. Done. Boom. Oh, 1 minute 41. That's a pretty good time. Oh, going through the test. Yeah, we do need to go through the test. Damn it. Okay. Okay. All right, fine. Haven't planned for that, but we can count. It means I've changed on my YouTube channel. Oh, okay. Share screen. I have no idea what the best way of doing this is. I don't even know what I did with that test. Connecting the protocol? No. I honestly don't know what I've done with it. Kinetics test? Here are all the questions. I can go through the questions one by one. Oh no. Is it out of sync? I've got a question that I haven't labeled. Oh no. Okay. Okay. I'll do it on, I'll fill it out as if I'm doing it. Oh, it just seems like such a long way of doing it. Did I not take like pictures of each one? Quick note maybe. Let me just quit. Oh, I haven't prepped for this. Ah, that one. Nope. That one. Nope. 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 It's all no. It's all no. I don't know where it is. What have I even done with it? I took pictures of it all and I don't know. Okay. Oh. Fine. Oh, Nikita, you properly threw me off there. That was a total curveball. Okay, I'll do it as if I'm doing it. I'll talk you through each one. You guys should have access to all your test results. Okay, kinetics test. Cool, so this was your test. And I'm gonna essentially do the test, pretty much. I could actually do it. I've got everyone's responses as well. Okay, let's just do it this way. Deduce the following order from the test. This is I'm going to take screenshots of everything. Okay. Oh man, I don't know what I've done with my paper version. I had a paper version. Just don't know what I've done with it. Okay. Order with respect to. Oh darn it! Order with respect to the other one. Okay, screenshot. Gonna have to do it the long way. Sorry, folks. I did not prepare for this. Totally my fault. My bad. Okay, so question number 1, order with respect to. So, by the way, I loved this question. By the way, I hope everyone realized that every single one of these questions that I gave you guys were off real papers. This was not just like me making them up and writing my own. I took every single one of these from an Edexcel paper over the last couple of years, and it's just been, and this first question was my favorite out of the whole test. Because the thing is, though, that nothing is staying the same. Everyone is changing, which means it kind of throws a bit of a curveball in here. But what you needed to look at was you simply said, right, let's look for the easy numbers. Oh, hang on, right. I doubled that guy. That's a times by 2. What did I do with this guy? Well, run my calculator. Run my calculator on that. One bigger divided by the smaller. 2.7 divided by 1.7. That went up by 1.6, give or take. What's the number done? It's gone up by 2. Right, that pretty much helps me straight away realize that chances are this is going to be first, yeah, and this is going to be 0. Most likely. Yeah, that kind of makes sense. Let's choose another 2. Yeah, let's just try a different one. Yeah, so this one we multiplied by 2.2 divided by 1.6. That's times by 1.375. This one has been divided, 3.6 divided by 2.7. That's been divided by 1.33. And what's happened to that? 3.2 divided by 2.3. And that one there has gone up by 1.39, which kind of makes sense. That ties into this guy. I loved that question. So the question number 1, the order with respect, you guys have all got access to your own answers. The order with respect to this is first. Yeah, it's a 1, and this one is a 0. I would have also accepted you to write first or 0, either 1, yeah, or, yeah, and like that. I know. I wouldn't recommend doing that dot thing, though. I would just, I'd actually write the words in, yeah, or 1 or 0. I wouldn't even bother with that. I don't like first, second, and then 0 because there's no, yeah, do you know what I mean? I don't like it very much, but not that it makes any difference. They wouldn't really care. Right. Next. Done. Question number 1, done. 2 marks. Question number 3, which one? Okay. So I need to go screenshot, full screen snip. So we've just worked out that this guy is first and this guy is 0. So mechanism number 1, which only has a single step, yeah, and it has this in the slow step, it can't be number 1. It can't be, because if that was the case, rate would equal k multiplied by this guy. I'm going to call that guy A, and this guy, and then CO. A to the power 1 and CO to the power 1. Yeah, but it's not there. So that doesn't make any sense. Yeah, we've got A to the power 1, and that's it. Yeah. So look at the next one. Slow step. Only that one could be true. The slow step contains only our first order reactant to the ratio of 1. That's totally reasonable. Yeah, and this one doesn't work either. So the answer is mechanism number 2. Number 2. Yeah, so that one's mechanism number 2. It's not complicated. Think you guys all had that. Yeah, next. Some of these questions, of course, some of these are more important than others. That one was an easy one. Okay, so tin metal reacts with iron 3 plus ions according to the following equation. For which of the following factors will increase the rate? Increasing the Fe ion concentration. Well, if we have to make a big assumption here that A is going to have an order. Yeah, that's what we have to make an assumption about. So if that's the case, increase the concentration will indeed increase the rate. Yeah, the next one, decrease the size of the tin particles. That's the equivalent of increasing the surface area. That one will also do it, both 1 and 2. We're done. Yeah, definitely. Finished. Next. Screen snip. Right, next one. Okay, so they've given us, just work out the rate equation. So this was an application of orders into rate equations. So this one went up by times 2. This one went up by times 2 squared. X is second order. So it could be D or B at this point, because that doesn't work and that doesn't work. Yeah, next thing is I'm going to double this guy, and this guy did absolutely nothing. So that one is 0 order. So the answer is B. Nice and easy. Yeah, moving on. First one of interest. Yeah, first one of interest. Yeah, because some of them, this is what I mean, some of them are really hard and they're designed to trip people up. The reaction between nitrogen and oxygen in the atmosphere under normal conditions is extremely slow. State one statement that best explains this. The concentration of oxygen, that's completely garbage. The molar mass of that is complete garbage. The frequency of collisions is lower than that of the nitrogen. What? No. That have sufficient energy. The answer is D. Yeah, we know that there's only, guys, we know to get that reaction to happen, we've got to break a nitrogen triple bond. There's only one thing in nature that can do it, and that's lightning. Yet the activation energy is chuffing enormous. The answer's D. Next, full screen snip. It's a long way around to do this, man, I tell you. Next, the reaction between our thought, the following mechanisms. Okay, another one of interest. So if you look at the equation, what you'd realize is that students think that you can choose. So this one's the slow step. Yeah, this one's slow, which means what I would like to write down is rate equals K multiplied by NO2 to the power of 2, because there's 2 of them in the equation. You'd never write that equation down like that, by the way. That equation there is written incorrectly. It would just be 2 NO2s going to NO and NO3. Yeah? Now, some students now at this point, now say, oh, well, hang on a minute. The NO3 has then gone back into this equation, which means, so by the way, D, possibly, yeah? The next thing is, could I not do B? And the answer is no, you can't. The reason being is 2 of those splits up to form these guys. What that means is an NO3 does not equal NO2 square to the NO2 twice. It doesn't equal that. It equals both of them. So that option now is out the window. So D is the only real option. We're done. Next. Doing well. Next screenshot. Okay. The rate of reaction between 2 gases increases when the temperature is increased and a catalyst is added. Which statements are both correct for the effect of these and changes of the reaction? So increase in temperature, collision frequency is increased? Not really. Activation energy? Hells no. Activation energy does not change? Activation energy increases? No. Yeah, activation. So that one technically and partially that one. Now, I've talked to you guys about this. It does actually do both. But if you increase temperature, you increase the speed of the particles and then say, oh, they're going to collide more frequently. But actually, over a short range of temperatures, because we came across the Argenius equation. K equals AE to the power of EA over RT minus EA over RT. And we came across this equation. And this here is called the Argenius factor. Yeah, the R factor. And that there is collision frequency and collision orientation. And we know that the Argenius factor remains almost constant over a short range of temperatures. What that means is this one is very limited. It's only got a very small impact on that. That one's much more likely to be correct. Adding a catalyst, activation energy, nothing does that. Activation energy does not change. Well, that's garbage. Activation energy, collision frequency, well, it's not. Okay, that activation energy decreases. Yeah, they're providing an I hate that. Provides a route with a lower activate. That sentence there is fundamentally that's Edexcel writing garbage chemistry. So the answer is going to be C. We're done. Moving on. Okay, it's full screen snip. By the way, if I make any mistakes, guys, please shout out on the classroom chat, because honestly, I'm as fallible as the next person. I'm doing this pretty briskly. Okay, by what factor will the rate of the reaction increase if the concentration of O2 are both doubled? Overall order. So the overall order of those guys, because oxygen is the power of 1 and NO is the power of 2, the overall order is 3. I'm going to increase the concentration are both doubled. So we're going to times by 2 to the power of 3. 2 cubed. 2 cubed. I'm doing it on my calculator. I know this seems, and the answer is D. We're finished. Moving on. Next. Oh, I loved this question. Oh, it was so pretty. Loved this question. So, which energy value will change when a catalyst is added? Okay, that's clever. Because we know that what we should have done is you should have drawn on this and gone, oh, yeah, there's the catalyst. Yeah. So, number 2 is definitely going to change. But also, therefore, number 3 as well. Yeah, number 2 and 3 must change. Yeah, so 2 and 3 only. The overall temperature change won't change, but the activation energy of both is both decreased by the same amount to boot. Yeah, it's nice that. Clever. Love that graph. Ooh, similar. What's this one doing? Let's have a look. The quantities, which of the quantities in the enthalpy change diagram below are affected by the use of a catalyst? Oh, 1 and 2. There we go. Fine. No idea why I've done a repeat question. Don't know how that slipped in. Don't know. Sorry about that, folks. Nice and easy, though. Makes sense in the previous one. Next one. Which step? Oh, no, no, no. What are you doing? What are you doing? It's doing so well. Oh, nuts. Full screen snip. Okay. Which step in a multiple step reaction is rate determining the slowest? Oh, isn't that clever? Love that. Everyone goes, where's the slowest? Where's the slowest? And which one's the slowest? Is D. The step with the highest activation energy will, of course, be the slowest reaction. Isn't that clever? Really like that one? Like it? Next. It's cruising through this, guys, on 12. Cool. So, what are the orders? Oh, so why have I gone and done this? Where's the trap? Yeah, it's second. Times by 2, times by 4. This is easy. What's going on? Stepping. Okay. No, it's not even an example of stepping. Ugh. That's a garbage question. Times by 2, times by 2. First. God, that's rubbish. Second and third. Done. That was way too easy. Didn't like that. Next. Okay. Screen snip. Please give me a shout out if I get one wrong, guys. Please, please, please. Are you all still there? Got 7 people watching. Next, which change will increase the rate of the above reaction when 50 okay? Oh, okay. The volume of HCl is increased. No. You know that the volume of acid won't make any difference. It'll make a difference to the volume of outcome if the calcium carbonate's in excess, but it won't increase the rate. Concentration decrease. Oh. Increase the rate? It says increase rate. So no. Size is yes. Pressure of CO2. Garbage. It's a product, so if it was on the other side, yeah. I'm glad people are still here. I've got 3 people willing to post on the chat. I feel like that's an indictment of my lessons. Oh, stop it. In a routine here, come on. Number 14. Next. Right. The reaction is the first order with respect to M, the second order with respect to Q, and M is this, and this is this, and this is this. What is the value of the rate constant? Rate equals K M to the power of 2, first order with respect to M, and second order with respect to Q. Right, reorganize. M, Q, go. Reorganize, input your data. Rate 0.01 over M 0.1 to the power of 1 multiplied by 0.02 to the power of 2. Gives me a rate constant. Any units? Yes. Moles, but nah, you see, yeah. 0.01 divided by brackets 0.1 times by 0.02 squared. Answer is 250. C, nice and easy. Oh, no wonder you guys found this easy, man. Yeah, it's an easy test so far. I feel like it's going to get harder, though. It's nice to see. Thank you guys for posting on the chat. It keeps saying, see, I'm looking at my YouTube now, and it says only 5 watchers. Who's watching YouTube? Tenzi, Ivan, stop watching YouTube videos whilst I'm teaching my lesson. Which statements are correct for the reaction? The reaction is second order with respect to A and B. Yes. The overall order of the reaction is 4. Yes. Doubling the concentration of A would have the same effect on the rate of reaction as doubling the concentration of B. Yes. All of the above. D. That's weird. All right. I'm only watching your YouTube video. I'm just playing around with you guys. Don't worry, fun. Next. Question 16. Right. Let's have a look with you. Okay. Which statement about Yorkshire? Which statement about following reaction, 100 degrees Celsius, is correct? Every collision between N2 and H2 is expected to... That's garbage. What's that about? This reaction must involve collisions of... No, that's not true either. Right, guys, that's the trap. Neither 1 nor 2. That's the one that loads of people are going to think that that's the correct answer. Right, you can't make that assumption, folks. Yeah, you can't do it. The reason being is we realize in reality, the chances of having a nitrogen being struck by 3 hydrogens simultaneously is really limited. And this is kind of recognizing that reactions can take place in multiple steps. We can't. The chances of that happening are like 0. It's just not going to happen. It's going to happen in multiple stages. It's going to happen at the catalyst surface, actually, by the way. But no, it's definitely neither. It's D. That's the trap. Everyone's going to think that that's true because the equation says so. It's not entirely true. There might be multiple steps. You don't know. Yeah, just don't know. Don't know. Do you? No. Okay, next. That's a trap, that one. Full screen snap. The rate of a chemical reaction increases with an increase in temperature. The increase in reaction rate is due to an increase in collision rate. Yes, a little bit. The decrease of the action, an increase in the number of molecules that react. Oh, technically 1 and 3 are correct. Technically. I'm going to go for C. I'd love to know what the answer is to that one. Guys, was it C? We can find out. The answer for that one is C. It is C. With those words, I would have put C because you have to accept that you run kick-ass. And it does impact both 1 and 2, just one very small amount. But it does impact it. Yeah, so hence the... my computer's having a bit of a freak out. Next. Screenshot. Hello. I can try to do it in a Welsh accent. Nothing very good at the Welsh, though. What is the order of reaction with respect to X and the order of the action is with respect to Y? To Y. I can't do... Sorry, I won't do Welsh. I'm terrible at it. Times by 5? Ooh. Bigger. 1 exponential minus 2 divided by 4 exponential minus 4. 25. Whoa. Whoa. Ah, times 5 squared. Second. Clever. Yeah, because that equals 25. Come back 25. Okay, next. Keep the same, 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 stay the same. Times by 5. Did nothing. 0. 0. X and Y. A. Done. Booyah. Booyakasha. 19. Yo, 19. Let's have a look. Hello. Value of rate constant, K, and absolute temperature can be determined by activation energy of reaction by graphical method. Which graph produces a straight line? Well, hang on a minute. We know that K equals AE to the power of minus EA over minus EA over RT. Right, we can then go LNK equals LNA minus EA over RT. We can then say that LNK equals LNA minus EA over R times 1 over T. Rearrange it, because this is my constant. Yeah. Y equals MX plus C. Yeah. Plus C plus LNA. There you go. So what we're going to do is we're going to plot. So if we now know 1 over T, we know Y equals MX plus C. We want LNK to be on the x-axis. if we want the rate constant, yeah, and the gradient, there's the gradient, E over R. So what we're going to do is we're going to plot that against 1 over T. Yeah, ln K versus 1 over T. D. There's my answer. And it'll produce a straight line. Yeah, there we go. Found it. Winner. Cool. Next. That was fun, that. Enjoyed that one. Next. Nice bit of Argenius there. Hey, Mr. Argenius. Next, the rate of gaseous reaction is given by the following expression. If the volume of the reaction... Oh, I got this one wrong. This was the one I got wrong. If the volume of the reaction mixture is reduced to 1/4. Right, so if you reduce the volume, you're going to quadruple the pressure. Yeah? So if you quadruple the pressure, which is the same as concentration, yeah, what's going to happen is you're timesing it by 4 to the power of 2. What's 4 squared? 16, right? 4 squared. 16. And it says new rate to original. New rate, 16 to 1. I got it wrong. I went for 116 because I got those two at the end backwards. Oops. Yeah, clever. It's deep. It's deep. It's deep. And the reason why I know that is because what I've actually done here, by the way, folks, is that P is order 1, Q is order 1. Yeah, and what that means is so these are orders 1 and 1. The overall order is 2. Yeah, so if I have multiplied the concentration of both of these guys, yeah, that's the same as going times by 4 cubed, which is multiplied by 16. Clever that. Yeah, because I'm timesing both of these by 4 in terms of concentration. Yeah, because if I quarter the volume, I quarter the size, which means the concentration is going to be quadrupled. We're done. Next, 21. Right. This is another mechanism one. So, following reaction. Now this one was the one that caused trouble. Because what you realize is there could be 2 here. The slow step. So if I go directly off that, rate equals K, and that's got one of these guys in it, and O2 to the power 1 and 1. So is that anywhere there? Yes, it's C. However, there's a trap, because 2 NOs produce NO2. 2 NOs, yeah, NO plus NO equals N2O4, N2O2, N2O2. What that means is I could also rewrite this equation. Did I just write equals? Did not mean to do that. Oh, no, I did actually. I could have also written this one. Equals K NO to the power of 2 and O2 to the power of 1. That's also true, which is D. So it could be either one of these guys. The answer, in fact, is D. Now, you guys are going to answer how I did not fail on a maths question. Yeah. So this one's awkward because you go, but it could be either C or D. Well, in reality, what's going to happen is the concentration of this guy really doesn't matter. Because what's going to happen is, because this is a 2-stepper and the fast one is first and the slow is second, if you've got an overlap in equations, you always use the one with the previous. The reason being is, if you just imagine this, yeah, what's going to happen is these guys are going to turn into this, but then it's not going to get used up. Its concentration is just going to climb as the fast step reaction happens. Yeah, but then so that can't be in the rate equation, because as that increases, then it would appear that as the concentration doubles, the rate would continue to accelerate, but it doesn't. What's happening is the concentration of this is remaining static, and these are producing it. I know that seems a really bad answer. I can't really explain it any better than that. It's because they're going to build up, yeah, which means its concentration won't matter. Yeah, you couldn't ever measure its initial rate. Yeah, I know that seems odd. So anyway, it's D. Sorry about that. 22. Doing well. Nearly there, folks, nearly there. 22. Consider the following statements. The rate constant of reaction increases with an increase in temperature. True. Increase in temperature decreases the activation. The term A in the Argenius factor relates to the energy required. No. Yeah, the energy requirements, that's activation energy. Yeah, A is the collision frequency. So it's 1 only. There you go. Done. Next. 23. I don't know if I've made any mistakes yet. Someone give me a shout out if I've got them all right so far. In general, the rate of reaction can be increased by all of the following except increase in temperature, increase in yes, yes, B. Oh, see, bloody hell. It's common sense that. It's just GCSE. Don't even. I've no idea how many questions there were, by the way. Next, number 24. Okay. The curve above is obtained from the reaction of the calcium, but how does the rate of reaction change with time? Rate of reaction decreases. Yes. It's definitely not increasing. No and no. Yeah. HCl becomes more dilute. Pieces become smaller. It's dilute. You're good. You have. Amazing. So A. In fact, guys, what you could argue is if they're getting smaller, their surface area to volume ratio will be increasing, but the using up of the HCl and it becoming more dilute has a much greater impact. So A, 25. Next, smashing our way through this. What is the definition of half-life for a first-order reactant? Yeah, the time required for the quantity of reactants to decrease by half. Yes. Oh, hang on a minute. Quantity. Don't like it. Half the time required for the reactants to... No. Half the time required for the reaction to reach maximum. No. Time required for the reaction to reach half its maximum. No. A. Easy enough. Easy enough. 26. It's easy enough. Next, for a given reaction, why does the rate of the reaction increase when the concentration of the reactants are increased? The frequency of the molecules' collisions increases. The activation energy, the average kinetic energy, no, rate is constantly increasing. What? Rate constant. Rate constant. The only thing that affects the rate constant is temperature of catalyst. A. 27. All right, let's keep going. I love the fact that these are all real questions. It's really nice. Some of them you're realizing are super easy. Then some of them are a little bit harder. Hydrogen peroxide decomposes in a first-order reaction. The half-life for the reaction is 60 seconds. In an experiment, the initial concentration is 0.1 dm cubed. The concentration of hydrogen peroxide after 120 seconds, right? So it's going to go from half, that's 2 half-lives. Yeah, so half-life number 1, it's going to take me to 0.5. Half-life number 2, it's going to take me to 0.25. I'm done. Oh, oh, so easy to miss a 0. Thank God that wasn't in the options. Lolcats. Say, winner. Whew. Blimey. That was nearly an easy hour. Numero 28. Oh, I don't want a keyboard. There we go. Full screen snap. Right, lads. Okay. Oh, love it. SM1, SM2. Bromo alkane was hydrolyzed by aqueous alkali solution. The reaction was found to be first order with respect to bromo, 0 order with respect to hydroxide ions. Right. So we remember primary halos. Yeah. Primary halos will go through SN2 with the intermediate. You can't do that anymore. Yeah. You go through and both. This is primaries are SN2. Yeah, pre-SN2. And then if we have a tertiary, because the delta, see that delta is massive. The delta on this guy is massively reduced. On the BR, it's exactly the same. Yeah, but now the OH minus suddenly can't see it anymore, so its concentration doesn't matter, which means it puts it into first order, and the OH becomes 0. So a tertiary will give me SN1. Secondary gives me both. So I now need SN1 because SN1 is 0 order with respect to hydroxide ions. So a tertiary, no, D. I'm done. There's the only tertiary on the board, all the rest are primary. Amazing. Next. How many questions did I do? Holy mackerel. Blimey. Getting bored, Mr. Duncan. Come on. Finish it, will you? The rate equation for the reaction carbon decomposes, rate of constant, workout units. Nice. S to the minus 1. Done. B. The way I've done that is, we know that we've got to know moles per dm cubed per second for rate. There's the rate units. Over, bring that guy down, moles per dm cubed, they cancel S to the minus 1 left. B. Love it. Question 30. Is this it? Last one? Yeah! Whoop, whoop. 30. Right, question 30. Oh, I love the fact it says number 3. Lovely. Uh-oh. Have I cut off the question? Oh, which graph shows how the rate constant of a reaction K changes with the temperature? See? Just got to know that one, guys. We know it increases. Yeah, but it's not linear. It's exponential. We're done. We are done. Look at that. I'm going to have to change the title of my YouTube video, like, immediately. Because that's not what I put on the YouTube video. No. Guys, we're done. I hope you found it useful to go through. Mr. Duncan, do you mind going back to question 2? Sure. Sure. Question number 2. Yes. Can. Yeah. Okay, Ivan. So question number 2, of course, is a direct spin-off of question number 1. If you couldn't do question number 1, you were stuffed on question number 2. Yeah, that's one of the problems with that. We just worked out that the complex at the beginning was first and the CO is 0. Yeah, you're not sharing your screen. Of course I'm not. I'm an idiot. Ignore me. Share. Man, I look rough today. Rough as toast. Lol. That one. No, that one. No, that one. There we go. So in question number 1, we've worked out their orders. Is that better, Ivan? Can you see that now? So what we've already deduced, and this is what we need to write down, is that this complex here, I'm just going to call this A. Oh. Screen snipped 1,000 times. It's amazing. So we have already worked out that this guy, that square brackets, this is the diaqua tetrachlororuthenium complex. Ooh, that's nasty, isn't it? There we go. Cl4, 2 minus. We've worked out that that's first order from question 1, and we've worked out that CO equals 0. Yeah, those are what we've already worked out. Well, if you look at the mechanism, the slow step must have the reagents in their orders. Yeah, and this is 1 and 1. Well, if that was true, and that being the slow step, that would have been first order. Yeah, we wouldn't have got 0. We would have got 1. Yeah. Does this one work? Yes, because only that's in it. That works in. That works. Next one, slow step. That doesn't work because of him again. Does that make sense, Ivan? Does that make sense? Oh, okay, cool. Unfortunately, it did totally hinged. I didn't know it related to question 1. Yes, exactly. Yes, you've got it. That was the key thing. It was the realization that question 1 and 2 were linked. Without that, you were just guessing. You'd never know what you'd be choosing. Yeah. Right, guys, I'm going to leave you be today. That's it for today, and I'll pick up equilibrium next lesson. It's been lovely to see you guys. Have a great rest of your day, and I'll see you guys soon. See you later.